Welcome to today's webinar, an introduction to Passive House Standard for Retrofits, what you need to know. My name is Jessica, and I am the Trade Show and Event Manager for the Western Retail Lumber Association. I'm your host, and I'm going to be the facilitator today for any questions you might have. Passive House Standard was first adopted as a tool to improve the quality of new construction. In the decades since its inception, the standard has grown to include some powerful new tools, guidelines, and certifications which can help professionals in the construction sector retrofit buildings to be more comfortable, healthier, and use less energy. Our session today is going to introduce the Passive House Retrofit Standard and highlight some examples of successful passive house retrofits from around the world. And of course, my first thing I have to do is I have to thank today's webinar sponsor, which is All Weather Windows. All Weather Windows is Canada's largest privately owned window and door manufacturer, launched in 1978 in a 10,000 square foot manufacturing facility in Edmonton, Alberta. The company has expanded services to across Western Canada to commercial offices, and they also have all weather windows glass and close to 800 dealers across Western Canada. With a combined capacity of over 300,000 square feet, their manufacturing plants produce a full range of award-winning, energy-efficient, sustainable, and weather-resistant window and door products for dealers. Company's been awarded the Energy Star, Canada's Manufacturer of the Year 5 times since 2010, and has been a Platinum Club member of Canada's Best Managed Companies for 7 years running and 13 years total. Congratulations, All Weather Windows. All Weather Windows is excited to sponsor this Passive House Standard for Retrofits webinars today with the WRLA. And they have a fabulous video I'm going to play for you guys really quickly, and we're going to enjoy that. Amazing. I love that video. It also concerns me when I see snow in the background, because then I'm reminded snow's coming. So just quickly before I introduce our two speakers, I just want to remind everybody we are being recorded. And if you want to ask questions, use the chat function or the Q&A function below there. So we'd like to welcome back Chris Ballard, the CEO of Passive House. Chris has a history of supporting environmental and land use causes, most recently as Ontario's Minister of Environment and Climate Change, implementing the government's plan for a clean environment and sustainable economy. He's also served as the Minister of Housing and the Minister responsible for Ontario's poverty reduction strategy and a member of the Treasury Board. He's a past executive director of the 6,000-member Consumers Association of Canada, the Ontario chapter, and a founding board member of the Consumers Council of Canada. His leadership in journalism, communications, and public affairs includes terms as president and board member of the Public Affairs Association of Canada. Welcome back, Chris. And we were super excited to welcome Ed May. He's another speaker for today from Building Type LLC. He's an architect and passive house consultant and an adjunct professor at the Parsons New School University in New York City, as well as industry professor at the Stevens Institute of Technology in Hoboken, New Jersey, where he's directed the 2015 Solar Decathlon program. In addition, he teaches with Passive House Academy, the North American Passive House Network, Passive House Canada, and is certified by Passive House Institute in Germany and Passive House Institute of the US as a certified passive house consultant. I hope I got all that in, guys. I am going to turn this session over to my two experts today. Thank you so much for being here.
Very good. Thank you, Jessica, and welcome everyone. Thank you very much for having Passive House Canada back again. Delighted to be presenting with my co-host Ed May. Really thrilled. Ed is an internationally recognized expert in all things Passive House, but more and more things that involve deep energy retrofits. So when we were asked to present on this topic, our first thought was to contact Ed and bring him into the loop, and so that you can hear directly from one of the leading experts in the area. So we're really excited to have Ed with us. So let's go to the next slide. Again, we have myself and Ed. A little bit about the agenda. We'll talk about why retrofit. We'll give an overview of the Passive House standard. We'll talk about certification for existing buildings and how to achieve energy retrofits with some examples. And then we'll have some information about training and information about our tower retrofit symposium. And then the really exciting part begins, questions and answers. So feel free to type your questions into the chat as we go along, or hold them till the end. But we're really excited to take your questions and provide some answers. It's always wonderful to begin dialogue. Next slide, please. So who is Passive House Canada? Well, we are a membership-based social enterprise. We do a lot of advocacy with industry, building professionals, governments of all levels, talking about the need for the Passive House standard. We do an awful lot of education and development for and next. The one who frankly, our mission as by government, public, support government, and we do by build standard. So next slide.
Chris, I'm just going to interrupt you. I think we're having some issues hearing you.
No.
I'm going to jump back in here because I think we're having some issues on Chris's end. Okay. Ed, would you be able to jump back in?
Sure, I can give it a shot. Are you able to hear me okay?
I can hear you okay. I'm going to just get Chris maybe to log back out and log back in. And Ed, if you don't mind taking over.
Sure, not a problem. Well, hopefully you'll be able to hear me okay. I turned my video off just to try and preserve some of the bandwidth here. So hopefully that's okay. Hopefully everybody can hear me all right. Hopefully everybody can see my screen okay. And if we have any trouble, I can try and log in from my phone. So bear with us. We'll see if we can get things started. So thanks to Chris for that kind intro, and thanks to Jess and everyone for organizing this session. As Chris said, my name is Ed May. I'm an architect and a Passive House consultant. I work down in the States, primarily in the New York City region. And I've also had the privilege of teaching with Passive House throughout North America for many, many years, both with the Passive House Network down here in the States and with Passive House Canada. So I'm really glad to be here with you today. And excited to talk to you guys about the Passive House Standard and how it applies to existing buildings, and give you a little bit of a sort of basic vocabulary and information around the Passive House Standard, so that when you hear clients and customers start to ask about it, you'll have some sense of what it is they're referring to. So let's jump right in. So today we're talking about retrofits specifically in the Passive House Standard. But why retrofits? What is it about retrofits that are useful, relevant, interesting? And are retrofits really relevant to a country like Canada? And in particular, does Canada really need the passive house approach to retrofits and rehabilitation of buildings? Let's talk a little bit about the existing building stock in Canada and North America more broadly, and then we can jump into some of the specifics around the Passive House Standard. So let's just start by talking about where we stand with our buildings across Canada. So Canadians, similar to most people in developing countries, are going to spend a lot more time indoors every year. More of our lives are lived inside buildings, and these buildings are really powerful shapers of how we live our lives, and as well as things like our health and our well-being. Unfortunately, a lot of these existing buildings have a lot of problems. For instance, as many as a third of all buildings in North America have some mold and mildew problem. Now, this is going to seriously harm the health of the occupants over time. Additionally, we normally think of our buildings as protection from the outdoors, but some studies have found that pollutant concentrations indoors can be maybe 2 to 5 times worse than outside. Again, seriously damaging the long-term health of the occupants of our buildings. And sadly, more and more the case that the outdoor environment is also getting more challenging. So in many parts of the country, pollutant levels outdoors are only going to make this health situation worse. So whether we're talking about industrial air pollution or smoke from wildfires, increasingly what we're seeing is that huge areas of Canada no longer have high quality outdoor air to help temper these indoor pollutant issues that we run into. So we have lots of health problems, we know that, both inside and outside our buildings. We also know that far too many of our buildings are really terrible places to spend a cold winter or a hot summer, whether it's due to a lack of basic insulation and air sealing, or an old and inefficient heating and cooling system. Most people who've looked at this have found that as many as 2/3, 2 out of every 3 homes in Canada report at least one room which is too hot in summer or too cold in winter, which is, I'm sure, not a surprise to anyone on this call. Certainly, it's something that most of us have lived through. In my own experience down here in New York City, I lived on the top floor of a 4-story walk-up row house built in the early 1900s, a perfectly nice place. But of course, there's not a stitch of insulation in the roof. And so when I come home on a hot, sunny summer day, the ceiling of my apartment is hot to the touch. It makes it incredibly unpleasant to be in that space and increases my air conditioning energy consumption. And I'm sure many of us on the call here could tell similar stories. And of course, all of this energy consumption used to create these unhealthy, uncomfortable spaces comes at a tremendous cost to the environment and the climate. We all know the CO2 emissions have continued to rise relentlessly and for decades. And building energy use for heating and cooling is a key part of the reason why these emissions continue to grow. Notably, a huge amount of this growth has come in our lifetimes. Worldwide emissions due to building energy consumption have more than doubled since just 1970. So we have unhealthy buildings, we have uncomfortable buildings, we have vulnerable buildings, we have climate issues around our buildings and energy issues around our buildings, affordability issues around our buildings. Given all that, I think it's clear, I think we could clearly say that Canadians deserve better buildings than the ones that we have. And it's up to us in the building industry to help improve building performance in terms of health, durability, comfort, resilience. And of course, the question that we have to wrestle with, those of us working in the high performance building sector, is how do we do all that? How do we build these better buildings that are healthier, more comfortable, more durable, and eliminate carbon emissions from our buildings? How do we do all of those things all at the same time? Now, luckily for us, we have some really fantastic technologies that are available to us as building professionals, whether we're architects, engineers, builders, or owners, that can help us to deliver buildings which are going to achieve exactly these results. So over the remainder of this session, what we'll do is we're going to take a look at a few different tools, techniques, and examples of some successful buildings which have achieved exactly the improvements that I've outlined already. So let's start by just talking a little bit about this passive house standard, what it is, what it means, and how we use it here in Canada and how it fits into this question. Now, the term passive house might be a new term to a lot of folks on the call, and it's worth taking a minute and talking about what we mean when we use that term. In my sort of judgment, the term passive house really refers to two very different things within Canada right now. So it's used to refer to a whole basket of different tools, techniques, and approaches to building better buildings. But that term, passive house, also refers to a very specific green building certification program along the lines of any other green building certification program you might be familiar with: LEED, WELL, R2000, et cetera, name your green building certification of choice. And that certification can be used to certify buildings and products and people. But at its heart, the passive house approach is focused on building better buildings. As we see, it'll become a bit more complicated as we dive into some of the details. Now, as a certification, a specific green building certification, which is available for people, products, and buildings, the passive house standard has been successfully deployed on tens of thousands of projects around the world for 30 years, 20, 30 years or so. The standard began in the early 1990s in Central Europe, and it's grown pretty rapidly worldwide since then. And of course, here in Canada, we have a pretty vibrant passive house sector, mostly focused around the coasts, as you would imagine, but certainly expanding rapidly. Now, as I said, the passive house standard can be applied to buildings, it can be applied to people, it can be applied to products, and all of these different certifications are developed and overseen by a group known as the Passive House Institute, which is headquartered in Darmstadt, Germany. But the certification or the standard is a worldwide global standard which can be applied to professionals or individual building components like windows or ventilation systems, or of course, whole buildings in any climate around the world. Now, we're here today to talk a little bit in depth about the retrofit standards that apply to these passive house buildings. So when it comes to buildings, the passive house standard has a tiered approach to buildings. You can certify as any different type of either a classic, a plus, or a premium building based on the energy performance of your building. That's for new construction. And then there's a whole specific retrofit certification, which has been developed over the years to allow for the design, engineering, and certification of specifically retrofit or rehabilitation of existing buildings. This is known as the EnerFit. That sort of energy retrofit, I think, was the original name. So a sort of portmanteau of energy retrofit there. And it has been developed in the last 15 years or so with a whole host of specific tools and methodologies, which are really helpful for those of us working in the retrofit sector. Now, retrofits are different than new construction. They're more complicated, they're more sensitive. You have to wrestle with issues of existing context. You don't have the freedom to form and shape the building, apply fenestration as you like. You're really hemmed in many different ways. In addition, there's always some sensitivity around the existing building fabric that has to be respected and paid attention to. And so as a result, what that means is the retrofits are harder and more complicated. And the EnerFit certification really helps guide professionals along that more complex certification pathway. All right, so we know we have a problem with our existing buildings, and we know that there is this thing called the passive house standard, and it has a retrofit approach. But what are the specific solutions that a passive house building is going to apply to a building in order to take it from a basic or existing building to a high performance, comfortable, durable, healthy, and low energy retrofit, a passive house building? We're going to use 5 basic strategies. 5 basic strategies are going to be the same no matter what type of building we are attacking. We're going to use insulation, air tightness, we're going to reduce thermal bridging, we're going to use high quality windows and doors, and we're going to install a dedicated ventilation system with heat recovery. Now, this will be complemented by a 6th point there, a high efficiency heating and cooling system. But today we're going to focus on those first 5. We're really talking about the so-called passive elements of the building envelope. These are things that aren't going to break over time. These are things that aren't going to get worn out. These are things that if they're designed correctly and built in, then they're just going to work for the life of the building. So we'll look at each of these in turn, but let's start with insulation. Now, I know what you're thinking. It's a perfectly nice day, and here I am sitting on a Zoom call talking about insulation. I know that's not a very sexy topic. It's not a very exciting topic, but the reality is that insulation is probably the single most effective tool that we have in our toolkit for improving the comfort and energy performance of our buildings. And so when it comes to passive house buildings, we're going to use high levels of continuous insulation around the entire building. And that's no different when we're talking about retrofits. This is a good example of a passive house retrofit that we can take a look at. This is in Ontario, in Hamilton, Ontario, the Ken Sobel Tower retrofit. Here you can see the building under construction. This existing building is a great example of the type of thing that we need throughout Canada. Here's an 18-story building. It was built in 1967. Terrible performance in terms of health, comfort, energy. But a valuable existing asset that needs to be preserved, a piece of the community here. How can we turn this into a building which will actually serve its occupants well? Well, they did just that in 2020. They fully rehabilitated this building to the passive house standard. They replaced the primary elements of the facade of the building with high quality components. They replaced the mechanical system, the ventilation system, and delivered a healthy building, a comfortable building, a low energy building. And one of the key pieces of that strategy was to completely wrap the existing building in a thick layer of new insulation. Now, of course, this approach, as you see in the photos here, is not going to be appropriate for every building. You have a heritage facade that you need to maintain. You're not going to wrap that in a new layer of foam insulation. But Canada has lots of buildings just like this one with completely unremarkable facades, which can easily be wrapped with a new layer of insulation, waterproofing, air sealing, and finish. And so this approach is going to be core to any passive house mitigation or retrofit that we're going to undertake. Now in Canada, when we insulate, insulation has to be paired with air tightness. And the primary role of air tightness in all of our buildings is to preserve the durability of the building. We want to make sure that we never have warm, moist air coming in contact with a cold, condensing surface. We want to make sure we never have any mold or mildew issues. We never have any health problems inside the building. And so air tightness is going to be a critical piece of that effort. Now, air tightness can be implemented on buildings in any number of different ways. And building an airtight building is really a team sport, as it were. It requires a combination of the specifiers, the product manufacturers, the designers, the detailers, and the builders all working together to make sure that they have the right products, that the products are being put together correctly using the correct applications, that the builders understand how to use those products, and that it's all done well. But you can use all sorts of different specific products in order to achieve air tightness. It just requires that the team select one set of products and then detail the building correctly. In passive house world, though, it should be noted that air tightness is something which is verified. In typical scenarios, we might say we build airtight. Some building codes require us to meet certain airtightness levels in our buildings, but it's been very rare historically for those building codes to require any testing or verification. Now, the passive house approach is very different. We're going to mandate or require that the building is actually tested after it's built. So when it comes to airtightness, you're going to have to prove it. You're going to have to actually show that you did build the building that you said you were going to build. So we're going to insulate the building. We're going to build airtight. Once we've done that, we're going to turn our attention to something called thermal bridges. Now, thermal bridges is a weird term. It's probably a new term for a lot of folks. So we can sort of talk a little bit about what it means, and we'll talk about the implications of thermal bridges. The short definition of a thermal bridge is anywhere that we have a break or a disruption in the insulation layer. Now, this can occur for all sorts of different reasons. Could be the parapet, which penetrates through the wall and roof insulation. Could be a cantilevered balcony, which penetrates through the wall insulation. Could be something like a roof drain or a plumbing drain. Could be any number of different elements which penetrate through the insulating layer of the building. what are the implications of thermal bridges and why do we want to remove them or design them out from our buildings? Well, the primary negative impacts that we see from thermal bridges are cold surfaces. And cold surfaces lead to both discomfort and a higher risk of mold growth. So anytime that we have a thermal bridge, we're at risk of mold and mildew, wet materials, and of course, discomfort in our occupants. Add to that the extra heat loss that we see as a result of these thermal bridges during the wintertime. And you can see why we want to focus so much of our attention on designing these aspects out of our buildings and using the right products to ensure that we can eliminate as many of these thermal bridges as we possibly can. So a lot of this is going to be figured out during the detailing phase, but especially when it comes to retrofits, there's a lot of thinking on your feet that happens and a lot of figuring out how to mitigate thermal bridges in the field. Because as you can imagine, when it comes to retrofits, you get a lot of surprises when you start opening up the walls. This is another good example of a certified passive house building built to the Retrofit standard. This one over in Vancouver, British Columbia. This is a single family home. So we looked before at a tower retrofit done to the Retrofit standard. This is a single family home done to the Retrofit standard. And you can see here, I'll just show a few sections here. I know we don't, not everybody on the call here is an engineer or an architect, so don't worry if these drawings don't mean a whole lot to you. But for those of you who are familiar with more technical drawings, what you can see here is the designer's approach to mitigating the thermal bridges in this project. Most notably, there is some structural steel in this building structure, this building envelope. As you can imagine, steel is much more highly conductive than insulation. So anywhere that we have something like a steel beam, we have to think very carefully about how we're going to manage or mitigate that thermal bridge. Here you can see they've done it through a combination of lots of layers of insulation. Yes, the steel beam exists. Structure is structure. We still have to hold the building up, but we can mitigate that thermal bridge by wrapping it in additional layers of insulation. So one of the things that characterizes passive house buildings is high levels of insulation in addition to their airtightness. And that's certainly obvious in this detail here. Now, the other thing we can say about thermal bridges when it comes to passive house design is that passive house designers are going to take a very, very careful and data-driven approach to mitigating and managing these thermal bridges. Now, time was, we didn't have a lot of great tools for analyzing, simulating, and designing out these thermal bridges. Nowadays, with the advances in computation, that's not true. We have some amazing simulation tools, which are very easy for practitioners to get their hands on, which allow us to execute detailed heat flow simulations of all of the details of our building and allow us to design out these thermal bridges from the get-go. What you see on the right-hand side there is a detailed false color image of the window installation situation of this project. And the colors there are showing temperatures inside the wall as a result of a heat flow simulation. So using these tools, designers can figure out where the problems are and then mitigate them. We don't have to guess. We can use these technologies to figure out exactly where the problems are and make our buildings better. Now that brings us to our fourth point here, which is windows, high performance windows. High performance windows are absolutely critical when it comes to designing passive house buildings, and retrofits are no different. So passive house windows or passive house quality windows are going to be absolutely required. And there's a few things that are going to go into passive house level windows and doors on a project. Now, if you've never seen a passive house level window, you might be a little surprised when you first come upon one. They're often quite a bit bigger than typical North American windows. They're going to be very highly insulated. They're going to be very airtight, often featuring at least 3 levels of gasketing to ensure airtightness. They're going to be thermally broken, of course. And they're in most Canadian climates, maybe our friends in Vancouver, BC might be exempt from this, but in most Canadian climates, we're going to require triple glazing in order to achieve the performance levels that we want out of our windows here. Now, in terms of the specific materials, there are passive house quality windows and doors made of aluminum, made of wood, made of PVC, made of fiberglass. It doesn't really matter. You can use any product under the sun so long as it meets the performance criteria. One of the things we haven't talked about too much in regard to the passive house standard is that it's a performance-based standard. It is not a prescriptive standard. It's not a checklist of things you have to achieve. It's a performance-based approach. model the performance of the building. And so long as you're meeting your performance, you as the designer, specifier, product supplier are allowed to use whatever methods, tools, techniques you think are best for your building. Puts a lot of agency and control back in the hands of the designer. Puts a lot of responsibility in the hands of the designer, but puts a lot of agency back in the hands of the designer and builder as well. Now, the other important thing about windows, and again, linked back to our performance-based approach, is the windows for a passive house building have to deliver thermal comfort. So they don't have to meet some specific level of some specific checklist, but they have to demonstrate that they can deliver thermal comfort passively to the occupants. And what that means, long and short of it, is that a window has to be good enough to maintain a, let's say, 18 degrees Celsius temperature on the interior face, even when it's really cold outside, let's say -12. Now, for those of you in Winnipeg, that might not sound very cold, but for a lot of parts of Canada, think Toronto, think Vancouver, -12 might actually be quite challenging. And so in those conditions, our windows have to be good enough to passively deliver thermal comfort. And what this means in practice is that what you don't see in passive houses is a bunch of radiators right underneath all the windows. This is one of the other things that characterizes passive house buildings, is a tremendous freedom when it comes to the heating and cooling distribution and system design. We do not have to put giant energy hog radiators right underneath all the windows in order to avoid condensation and discomfort when we design passive house buildings and use passive house level products like passive house windows, doors. So absolutely critical to a successful passive house building. Now, the last of our 5 points here, insulation, air tightness, thermal bridges, windows, is ventilation. Ventilation, by my estimation, probably one of the most important pieces of the puzzle when it comes to designing a healthy, modern 21st century building. What do we mean by ventilation? Well, let's talk a little bit, before we talk about passive house ventilation, about typical Canadian ventilation. Maybe some of you on this call live in single family homes. Maybe some of you live in apartments. But for those of you who live in single family homes, you might be familiar with a system like the one here. So how do we get fresh air for people to breathe into most Canadian homes? Well, we sort of rely on a couple different mechanisms. First and foremost, we rely on the fact that most of our buildings are not built very well. And so usually we're going to have an awful lot of air leakage through the envelope of the building. So we don't have to worry a ton about volume of outdoor air coming into our building. Now, as the air leaks through the envelope of your building and washes across desiccated bug parts and mouse feces and everything else, is that air clean by the time it gets to your lungs? Well, that's a whole different story. We can talk about that another day. But suffice to say that there's plenty of airflow pathways for outdoor air to make its way into your home. Now, you might also have some sort of an outdoor air damper, which might feed into your heating and cooling system. And then you might supply some nominal amount of fresh air off to the spaces, but only riding on the heating and cooling system. And then you might have a extract air system in the washrooms or in the kitchen, where you're taking air out of those spaces and voiding it out of the buildings. So that's a very typical fresh air ventilation system for a Canadian or North American home. Certainly we see plenty of this down here in New York State where I work. Now, a passive house, by contrast, is going to function very, very differently. So first of all, we have almost no air transmission across the envelope of the building. That means in wintertime, the cold air stays out and the warm air stays in. That means in summertime, the cold air stays in and the warm air stays out. We have a very airtight envelope. And so we are going to use a mechanical ventilation supply. We're going to use a machine to bring filtered, clean, fresh air into the building 24 hours a day, 7 days a week, 365 days a year. This same machine is going to extract stale air out of the home 24 hours a day, 365 days a year. What results when we configure and design and build a building this way is an incredibly healthy and comfortable home, one where we have very, very high quality indoor air, where we are constantly extracting pollutants out of the home and constantly filtering and supplying fresh air into all of the main living spaces inside of the home. This approach is going to lead to a much, much healthier interior environment for the people living inside of our building. It's also going to help to improve building durability. It's going to reduce the likelihood of mold or moisture problems. It's going to radically change the way these buildings behave. Now, if you're not familiar with these machines, you soon will be. These are being written into virtually all northern climate building codes at this point. Certainly, we're seeing this happening down in the States, and it's been the code for quite a while in places like Ontario. These heat recovery or energy recovery ventilators are new gadgets. They're new pieces of equipment that we're adding to these passive house homes. Now, these machines are not very fancy. They're in fact quite dumb. It's a foam box with a few fans in it and some high quality filters. All of the sophistication comes in two places, both the controls, but more to the point, the heat recovery core of this machine allows us to do something like take minus 12-degree air and bring it directly into the house 24 hours a day and not pay an enormous energy or comfort penalty. So this free heat recovery that happens inside of this machine is really where the magic happens. Other than that, it's actually quite a simple machine, but it is a new piece of equipment that needs to be added to these high performance modern homes that we're building here to the passive house standard. So we put all those pieces together, we build an insulated building, we build it airtight, we design out all of those thermal bridges, we specify and install high performance windows and doors, and we add in a really high performance fresh air ventilation system. We complement that with a high performance heating and cooling system, and that's going to get us to that Retrofit level of performance. So let's just talk briefly about achieving that Retrofit certification, and then we'll wrap up here with plenty of time for questions and answers. So how does one go about designing and engineering a successful Retrofit project? Well, the first step is to, as I noted earlier, simulate the entire building performance. So as I noted, the passive house certification is a performance-based approach. It is not a checklist of things you have to do. You, as the architect, engineer, owner, specifier, are responsible for figuring out how to build the building. This is one of the things that I like the most about the PHPP, or excuse me, the passive house approach, is that it allows me as the architect, as the engineer, to do what I think is best for the building. I'm not beholden or locked in to somebody else's notion of what a good high performance building is. There's a very few, very clear, very hard limits on what it means to be a passive house. But so long as you achieve those, then you're a passive house, and you can achieve those in any number of different ways. But the way we validate that, the way we verify that, the way that we design our buildings from the beginning is by simulating the performance of the building. And we're going to do that using a piece of software known as the PHPP, the Passive House Planning Package. It's a proprietary piece of software that we use to simulate the energy performance and thermal comfort and durability of our building during the design phase. This allows us to make smart decisions about how we're going to build the building during the early phases of design. We don't have to wait until the building is operational, stand back and go, that didn't work. Let's try something else. We can actually try various different approaches in the simulation and decide on these things during the design phase. As I noted earlier as well, we have a whole host of other amazing new simulation tools at our disposal as architects, engineers, designers, specifiers, when it comes to things like envelope design, when it comes to things like hydrothermal analysis, moisture issues inside of our building assemblies, as well as heat flow simulations for designing out things like thermal bridges. So all of these tools are now available to us, and we use them very heavily during the passive house Retrofit design process to, again, ensure that we're building the highest quality, smartest, best modern building that we possibly can, and that we're not introducing any unforeseen issues into the building fabric. This is particularly important when it comes to retrofits. Again, we need to be very sensitive and thoughtful about that existing building fabric as we start monkeying around, adding new insulation and new layers to those types of buildings. Of course, all those tools are worthless without the education to use them properly. And that's where somebody like Passive House Canada comes in. Passive House Canada, the group that we're here representing today, an amazing group of practitioners and dedicated folks up in Canada, working across the nation to provide education and resources to those who want to learn how to build these modern high performance buildings. And so Passive House Canada maintains a whole universe, whole ecosystem of different types of training, both live, in person, and on video, as well as on demand video trainings through their website there. So if you're interested in any of that, I would highly recommend that you check out that Passive House Canada website. There's as I said, a tremendous amount of really valuable education that is available there through Passive House Canada. Which of course is really important to anyone who actually wants to achieve a high performance passive house building. You know, the knowledge of these various tools, techniques is critically important and can't be ignored. So Passive House Canada, really important piece of the puzzle there for sure. And with that, I'll bring us to a close. So as we talked about, when we implement all of these various strategies, we get a comfortable building, we get a healthy building, we get a durable building, which is resilient, and of course, low energy and low emissions. So with that, I will turn it back over to Chris. Chris, hopefully you're able to finish up this part. If not, if your connection's not working, not a problem. I can go ahead and complete this if not.
We're back. The internet
Right.
the gods of the internet have decided that I can carry on. You know, it's the chance of your internet crashing is directly proportional, I think, to the importance of what you need the internet for. So I apologize for technical glitches. So thank you very much, Ed. You know, as always, thank you for a really great oversight about what Passive House Interfit is and the Passive House principles. You know, my thoughts are that, and I know the audience we're talking with today, looking forward to some questions. But my thinking is that, you know, in the months and years ahead, as more people come into stores to inquire about, they want to retrofit their homes, their buildings. Contractors may be coming in and looking to do some deep energy retrofits for clients. Passive House is the way to go. So it's been wonderful to be able to introduce folks to that Passive House principle when it comes to Interfit, retrofits, so that you're a little bit more prepared. And a lot of the products you see today that are used in Interfit are already available, I suspect, in your stores. And I'm really delighted to see more and more Canadian manufacturing of Passive House quality components, whether it be windows and doors or HRVs. More and more Canadian companies are stepping up and making the equipment that we need to make sure that more Interfit products are going ahead. Wanted to touch on something really exciting, though. We've got coming up at September 22nd and 23rd is our Tower Retrofit Symposium. Passive House focused on single-family residence in the early days, but we've really grown here in North America and Canada to include large towers, MURBs, that sort of thing. And there's real interest on how we Interfit, do deep energy retrofits on towers. So September 22nd, 23rd, we've got a great symposium happening. I would like to offer to WRLA members a discount off that symposium. It's regularly $562, but we're offering a discounted price of $250 for WRLA members, because it's that important for all of us to learn where the world of retrofit is going right across the country as building codes are ramped up and the need to Interfit tall buildings becomes more critical. This symposium will help kick that off. So we'll put up a connection information in a minute. Next slide, Ed. Well, that's it. Next slide tells you where you can get more information. So come join us at passivehousecanada.com. Email us for more information. Give us a phone call if you want to learn more about all of our courses, and especially about the symposium. It's really important for us to be there. And I want to just take a minute and thank, before we get to our Q&As, I want to thank once again WRLA for inviting us to speak to your members today. It's really important and really great to be here. And I have to say one thing before I go, you know, that Passive House itself has some of its DNA right there in the Prairie Provinces, because we have the Saskatchewan Conservation House, built in 1977, that's been recognized by the International Passive House Institute as one of the fathers, we'll say, or mothers of the modern Passive House standards. So, you know, the Prairie Provinces should feel really proud about being part of an early adopter, we'll say, an early driver of the Passive House moment. So back to you, Jess.
Oh, well, thank you. First of all, thank you for the information on the Tower Retrofit Symposium. I've put up the information in the chat, and I'll also make sure I'll email it out to everybody. And thank you very much for that huge discount if anybody would like to attend. Just a reminder, if you have questions, to use the chat function or the Q&A function. I'm watching it right now. I do have some questions, which I think the first one is, what are going to be the next steps for finding resources for some of our members? Where should they go? What's the best place? Obviously, the best place to start probably be the website, but is there anything specific that you wanted to highlight for people sort of getting familiar with Passive House?
Well, of course, our website has all sorts of information, and that would be a good place to start data mining. You know, subscribe to the newsletter. It's free, and that's a good introduction to the Passive House community across Canada. And from there, there's great networking and great opportunities can grow from there. On a more technical perspective, maybe I can bring Ed into the conversation here to talk about what resources are available. You know, one thing I find Passive House is really good about is that there's a lot of cooperation. So we will have competing contractors, architects, engineers. They may be competing during the day, but after hours, they really like to help each other. It's been a wonderful introduction to this group to see that happening. Ed, do you have suggestions?
Sure, it's a great question. I think probably what I would suggest is that it's really important to get engaged with your local community. So the Passive House Canada website, as you got up on the screen here, is a great first step. But of course, as everybody I'm sure on this call is aware, British Columbia, Vancouver is very different than Winnipeg, very different than Ontario, very different than Halifax, right? These are going to be very different local markets with different needs, with different product availability. And so getting engaged with your local Passive House group is going to be really, really valuable, and is going to teach you a lot about the local issues that those groups are struggling with. You know, the folks and the types of products that are working and being used in downtown Toronto will be very different than those that are available in more rural areas. And so trying to gain a better understanding of the specific region that you're working in and supplying is really, really useful. And so I would just note that there are lots of regional groups throughout Canada, and that I would strongly recommend that you get engaged not only with the national level group, but with your local community groups, your local practitioners as well, because it'll often be quite a bit different in different regions, different areas. You know, the specific needs, specific product types, specific project types that people are working on and struggling with.
Yeah,
awesome.
Good advice.
Thank you. That's great. I do have a question here about what is the cost? Do you have an average cost per square foot for cost of retrofit? Normally, what an average consumer would expect to be budgeting for?
Ed,
is that too vast a question?
Yeah, it's almost the same as, because it would depend. I hate to give that answer. It depends on the building form to begin with, and what outcomes what outcomes we want. So, Ed, you've got more experience than I do.
Well, no, I think it's always a really great question, but it's a hard question for just the reason you highlighted. Well, let's start with this. What does it cost to build a building? Well, what kind of building? Are we talking about a tower? Are we talking about a single family home? Are we talking about a masonry structure? Are we talking about a wood structure? Are we talking about a rural location or an urban location? There's so many things that go into it. So the answer has to be, it depends.
Okay.
Now, that said, I will say that when it comes to retrofitting these buildings, what we find, and this is the recommendation from the Passive House Institute, is that it's not typically going to be cost effective or sensible to undertake a energy retrofit on its own. What do I mean by that? Usually the way that we would recommend to undertake these types of improvements is when it comes time to retrofit the building, when you need to fix the building already, because if it's extended or it's gone past its useful life, the roof needs replacing, it's now no longer functional from a spatial perspective. When it's time to start replacing and fixing the building, upgrade your components to the highest quality that you possibly can at that time. So it's almost never going to be really cost effective to just tear a perfectly good roof off a building and put a more insulated roof on a building. But when it's time to replace the roof, add that extra insulation at that time. So typically when it comes to those types of cost effectiveness measures, we have a whole host of different strategies that we would employ and recommend when it comes to the sort of most effective way to do these things. But that would be the short answer for how to do it in the most effective
No, I appreciate that. It is a bit of a vast one. And I guess going back to those the resources, is that something that resource-wise is offered? So if you are thinking like, hey, we need a new roof, you have that checklist sort of at the Passive House standard, or is there recommendations for something like that?
Well,
go ahead. Well, I was going to say, so as I said, it's a performance-based approach. So it's not a checklist approach. So it's not like a list of things you have to do. It really does put a lot of the agency and responsibility on the design and specification team. It's really up to you to figure out what your building needs and how to best achieve it. Now, there's a lot of guidance and help, and you'll have the assistance of the Passive House community, but nowhere will you find a Passive House policeman coming by and saying, oh, you didn't do the roof right. You didn't check the box correctly, right? It's a performance-based approach. As long as your building works, then you do what you need to do, which again is one of the reasons why I love this approach so much, is because it puts so much of the authority and the power back in the hands of the designer, the specifier, the engineer, and the owner, rather than some sort of agency in Germany with a checklist somewhere, right? That's not what this is. So it's a very different approach.
Good. Yes, if I can jump in for a second too, because Ed makes a really good point that you're not going to tear off a perfectly good roof to replace it with a better roof, or you're not going to tear out perfectly good windows to put Passive House windows in. One of the reasons we're running the symposium is that we know there are about 10,000 towers right across Canada that were built in the 1970s, the 1980s, that are in dire need of just basic renovation right now. So the windows are failing, wall systems, mechanical systems are failing, and it's time for them to be renovated. So we've put the symposium on because there is a lot of those questions about what do we do? Do we replace the windows, replace that? And what we're saying is now is a wonderful opportunity. If you're renovating your building, if it's at the end of a lot of the components are at the end of their life cycle, now's the opportunity to replace them and do an retrofit on your building.
You're giving them a start point to know what they need to know, that step of decision making, kind of.
Absolutely.
That's great.
And we hear from folks like Ed all the time, owners especially, who say they like the Passive House approach because it puts control back in their pocket. They're not bound by some organization. They get to be creative in sorting out the solution. All we require at Passive House is that the outcome has to meet a certain goal.
Okay, great. So do you have sort of a profile of an individual that typically likes to take on a Passive House project? Is it a specific age group? Is it younger? Is it older, retirees? Who are the people that are really picking up the Passive House baton and running with it?
It's interesting, and I'm sure Ed will have some comments. He's been involved with this for a long time, but my sense is that in Canada, the early adopters were folks who were interested in single family residence. They were aware of the environmental challenges we face, the climate crisis. They were looking for some things they could do to help mitigate that. And they were drawn to Passive House. With a little bit of research, they were drawn to Passive House. Interestingly, now, what builders of passive houses tell me of single family residences is that they don't sell their homes based on them being a passive house. They sell homes because passive house is really a health and comfort standard. And if you build to the durability of passive house, you get very low energy. So selling a house based on really low energy, or a passive house on really low energy consumption, isn't enough. But people tend to buy passive houses because of the health, the comfort, the quality of the build, and the fact that that it's low energy. The great thing too is that we're finding across North America that there used to be a little more significant cost premium to build to passive house, but that's been driven down as more products are manufactured in North America. More people become expert and experienced at building and retrofitting to the passive house standard. So I would say now, I don't have a profile of a typical passive house. You know, we have business people, building owners who want to drive down energy costs and create a better environment for their renters. But, you know, they're being driven by, they can make the economic case to do an interfit. And we still have homeowners who stumble upon passive house and want one for themselves. So it's really growing exponentially. Passive House Canada started by pulling together a bunch of regional organizations. Our headquarters is in Victoria, but we've had massive growth right across the country from people from all walks of life. Ed, anything to add to that?
No, that's a good summary. I guess from my perspective, I would break it up into at least 3 different sectors. I would say there's at least 3 different types that we see come through our office. So we've been doing passive house for about a dozen years or so down here in the New York City market. And of course, New York City, it's its own ridiculous universe. So take this all with a grain of salt, obviously. But I think what we have seen is that you absolutely have your homeowners. So you have folks who own their own home and want to retrofit it or build it to the passive house standard. They're primarily interested in the comfort and wellness benefits, as you alluded to, Chris. The environmental benefits are also very important, but it's not what draws them to passive house. What's selling them and drawing them to passive house are those comfort, durability, health, and wellness benefits. And then if they can say they got all that while emitting less carbon and doing a better job on their energy efficiency, that's a great easy sell for our owner clients. Now, there's another type of client, though, which are the multifamily buildings. So we have a lot of professional developers who are pursuing passive house for their multifamily buildings. They're large buildings, 1,000 units, however many. And they're doing it for a host of different reasons, primarily around financing and marketing. So there's a couple of really important finance levers that have become available here down in the States for financing these types of buildings. So they have a bit of an edge against their competition when it comes to securing financing through different lenders if they commit to the passive house standard. And then they're able to market their buildings to a different clientele. So they're able to build a higher quality building and market them as a higher quality, more environmentally friendly and healthier building to different types of clientele. And then there's a third bucket down here, which is the social housing community. So the passive house approach has been very popular with certain social housing or affordable developers down here in the city, primarily because of the cost savings on the operational energy side. Now that's particular to that sector, though, because of course those types of buildings in the US at least don't pay property tax. And so as a percentage of their yearly outlay, their operating costs are very significant. So if they can reduce those, well, all of a sudden they can build a very different, bigger building. They can build more units. They can do all sorts of stuff on the lending side, which enables them to build different buildings. And so there's 3 very different sectors that are pursuing it for very different reasons. And so I would break it up at least that far. I'm sure you could break it up even, find a few more sectors if you really thought about it. Right. That's certainly what we see.
Okay, well, that's wonderful. Thank you for that, and that's really interesting too to hear that, especially from your side of the border, just to learn a little bit more about that going on there, because I wouldn't have even thought about some of the social housing aspects of it too. That's great. Thank you.
Yeah, and that just to reiterate what Chris is, what Ed is saying, here in Canada, we find the same thing. One of the
Okay.
largest adopters of Passive House
Mhm.
and Passive House Interfit are social housing
Oh,
agencies who recognizing the significant savings. Well, the other thing I was quickly going to throw in, I'll make a pitch for Passive House, and if you've got any manufacturers, and I saw who I know who the sponsors of today's show.
yes.
You know, when we talk about social housing, one of the largest social housing provider in Canada is Toronto Community Housing.
Mhm.
And they have adopted the Interfit standard for their 200 plus towers. They will be interfitting in the coming years, and they estimate they will need 200,000 plus of Passive House quality windows in the next few years. So attention, Canadian manufacturers. If you want more details, talk to us. We're working with Toronto Community Housing. We're working with Fenestration Canada to develop a standard specifically for Toronto Community Housing that will be Passive House quality.
Wonderful. Thank you so much. Okay, that's amazing information. I think